Those at home, print out 2 of those of you at home. Those of you here, on one of them, write on top, work in progress, and then on one of them, write best copy or final copy or the best one. So we're going to do one, we're going to do all sorts of writing on, and then one we're going to try to do to make it really, really nice, okay? So we got one work in progress, and then as the work gets better, then we're going to write down a really good one, First of all, what you have in front of you is called a unit circle, and let me just show you what that is. It's actually a sheet of graph paper, and all that you see is just this little bit that goes over to 1, up to 1, back to 1, down to 1. That's what this is. This is a little sheet of graph paper that just the little part right in the middle of the graph paper. Right on the graph paper. All right. If you would notice, I'm going to just draw one that is adequate, certainly not as good as the one you've got in front of you. And right here, folks, right here, on your work in progress, if I were to start an angle, and don't do this, but if I were to go straight out, and then I would rotate it none, not at all, how many degrees would that be? Would you all write on your work in progress, 0 degrees right there? On your work in progress, write 0 degrees. All right, I bet you people know that when you go a quarter of the way, this is how many degrees? And would you please put 90 degrees up there? All right, so that's not rocket scientist amazing. All right, would you please look at these 2 points? Do you all notice there's sort of 3 points? For a moment, please ignore the one in the middle. Please ignore the one. Please ignore the one in the middle. This is nothing official, but with your fingers, would you measure from here to here, then here to the next one, and here to the top? So from the 0 to the first dot, we're ignoring the middle one. The 2 that we're talking about and the other. By measuring my fingers, there's nothing official by that, but do they seem to be the same amount apart? Yeah, it does. In fact, are we most likely cutting that in thirds or dividing by 3? What's 90 divided by 3? No calculators. Would you put 30 on the first dot? Skip the middle one. Would you go to the next dot, add 30 more? What's that going to be? It's going to be 60. Do you notice the answer is yes? 3 dots right here, 3 dots right here, and 3 dots right here. Would you please ignore the middle dot on your work in progress, and please continue ignoring the middle dot and keep adding 30. Keep adding 30. So you got 30, 60, 90, then the next will be 120. Then 30 more, 150. All right, this is the work in progress, so if we need to fix things, we can fix things. We're all going to go together. Everybody, 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330. Awesome. All right. Still on your work in progress, did we ignore the dots in the middle? All right, that was only temporary. We were only temporarily ignoring the dots in the middle. Would you please, with your fingers, and there's nothing official about this, please measure from your fingers to 0 and then your fingers to 90. Do they seem to be about the same length?
Yes.
What is 90 cut in half?
45.
45. Would you please put 45 on the first dot? What's 45 plus 45? 90. Oh, guess what? It works just like that. Would you please fill in the rest of those dots? All right, all the way around the circle. Here we go together. 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330. Would you please nicely and neatly on your good copy now, on your good copy, as nice and neat as you can. We're going to be adding much more to the good copy, so nicely and neatly on your good copy. If you mess up, hander outer people, are there plenty of extras? Yeah. Yes, there's plenty of extras if you mess up on your good copy. So on your good copy, 0, 30, 45, nicely. Bless you.
Can I use the bathroom?
Mm-hmm. Did the Kleenex run out? All right, we're gonna have to go toilet paper those that need it. At least it's something. All right, excellent. We're going back to our work in progress now. We're going back to our work in progress. And on our work in progress, I'm going to remind you of something. That the picture you're looking at is really a sheet of graph paper right here. It's just that little bit from 1 to 1 to -1 to, that's what you're looking at. You're looking at just a little bit of a graph paper. We're not looking at the whole rest of the graph paper. All right, so let me see, here we are again. Wow, that didn't go well at all. That went, in fact, poorly. Oh, it looks like a balloon. All right. If this is a sheet, we're on the work in progress page. This is 0 degrees. If this is a sheet of graph paper, which it is, this point is over what, up what? Over 1, up 0. Would you please put 1, 0 right there? Because this is just a little bit of the graph paper. And up here on a sheet of graph paper, this is over 0, up 1. And this one is back 1, up 0. And this one is over 0, down 1. All right. Do I have to stop the recording yet? No. All right. So far, so good. Well, it's time for you to raise your hand to one of 4 responses. The question's going to be, did you like geometry better than algebra? Algebra better than geometry? You liked them both? You didn't like them both? One of the 4. How many like geometry better than algebra? Okay, got about Number 4. How many like algebra better than geometry? We're 20-ish. How many like them both? 1, maybe 1.5. How many don't like either of them? 1, 2, 3, 4, 5, about 6. There we are. Well, we're going to do a little geometry is what we're about to do. We're about to do a little bit of geometry. And then this geometry, I'm going to draw a triangle that has the following. This triangle has 30 degrees, it has 60 degrees, and it has 90 degrees. Now, irrelevant whether you liked or didn't like geometry, how many had a teacher that actually you talked about a triangle that was 30, 60, 90 degrees? Quite a few of you did. Awesome. That's awesome. Say, what's the radius? Geometry word from here to here. The radius is 1. The radius up here is? The radius here is? Hey, in a circle, are all the radius always the same? The radius 1. I'm going to put a 1 right here. So that's 1. Just like it's the radius. We can pretend like that's somewhere where the radius is. I wonder what the other ones are. Well, I'm going to prove something. Prove, but not 2-column proof. Just show you proof. All right. Said the word proof. A few people didn't respond well. I'm going to draw an identical triangle right here. An identical triangle right here. It's the same triangle. It's just the earth is curved if it doesn't look exactly the same. It's an identical triangle. So this is 30. This is 60. This is worth 1. It's the curve of the earth. Say this angle is 60. Forget about the line in the middle. This is 60. This is 60. That was called an equilateral triangle or equiangular. Equilateral, equiangular. If this is 1, this is 1, what's this? That's 1, because they're all 1. Now watch this. It's called the eraser. I just erased that again. Say, if the whole thing was 1 and I erased half of it, how much is this? Oh. And those that said 0.5 are correct. We're going to use 1/2. However, we're not going to use 0.5. Well, there was that Pythagoras person. And I'm going to go a squared plus b squared equals c squared. A squared plus a fourth equals 1. Take away a fourth, a squared equals 3/4. Throw a square root sign on top of that. Square root of 3 over square root of 4 is the square root of 3 over 2. And I'm going to put right here the square root of 3 over 2. Well, how dandy is that? And I'm going to stop this recording.